I hope that chapter one went well for you. And don't forget, you can keep re-looking at the video that I recorded for you for chapter one. And hopefully that will help. You might have to look at it a couple of times if you do. And if you still need help, like I said, let me know. So here we are. We're in chapter two of Applied Business Math. And this chapter I called Fundamentals Part 2. Remember that we called the other one Fundamentals Part 1, and so we went into numbers and number lines and things like that, just starting to look at numbers, starting to look at fractions and decimals and things. So this chapter is mostly, or it's all on percents. And I have this whole chapter on percents because, we look at percents all the time in our everyday lives, whether it's our personal life or our business lives as well. And you could use them in different ways. If you're in human resources, for example, you might need to be calculating salary increases and by percentage, by a percent change. If you're an employee of that same company, you want to make sure that the HR person did it right, right? So we're going to want to see that too. So there's a lot of ways we can look at percentage. And so we're just going to go through the chapter and kind of go through the examples. I also wrote some stuff down. I know it's hard for you to see that, but as we go along, I will go through that with you. And if there's anything that looks like that I want to, give you a little cheat sheet for or whatever, I'm going to do that too. There's a couple of things on here that might be worth knowing, just in a small little area, kind of like knowing formulas, right? Okay, so for example, we're going to look at these three statements. The first one is during the 2012 election, Barack Obama received 51% of the vote. The second one is Tom's earnings place him in the 24% federal income tax bracket. And the third is in January 2018, the average unemployment rate in Louisiana was 4.7%. So we want to interpret these statements, okay? So that's what we're going to look at first. So when we say during the 2012 election that Barack Obama received 51% of the vote, we are saying that 51 out of every 100 voters, or 51 hundredths, remember hundredths from last time, of the voters cast their ballots for Obama. The other 49% would then have voted for somebody else. So you see how we have 100, it's out of 100, okay? 51 over 100. And what's 100 minus 51? 49. So that's where we get the other percentage, as far as that is concerned. A percentage is a hundredth, or the number of parts out of 100. So that's just an idea of how you can think about that. So we have this next statement. It seems pretty straightforward when we first look at it. Tom's earnings place him in the 24% federal income tax bracket. Okay, so 24% is 24 out of every 100, right? So that would probably mean that of every $100 he makes, the federal government's going to take out $24 in tax. Okay, see how that works? But we all know that taxes are a little bit different than that. It get more complicated because, sometimes there's a percentage on one part and not on the other, or, you have the deductions that can come out. So it's not always exact, but that's kind of what we're looking at here as well. Okay. So basically looking at what the 24% is a part of. And As far as the salary, is it his gross salary? Excuse me, is it his net? Is it a portion? So the quantity to which it refers is the base. Okay, the base is usually the object following the words percent of. Okay, now let me look at my notes, make sure that I'm going through. Okay, so example 3. In January 2018, the average employment rate in Louisiana was 4.7. Okay, so what's the unemployment rate? The portion of people in the labor pool, so all those who are willing to work who did not have a job. So the base is that total number of people in the labor pool. Okay, just like the base on the last one was, and you can say population, maybe in some cases. Typically, it's really a sample. We'll get into those things later. You'll see that later. But so the base of the number in this situation is the people in the labor pool. So 4.7 out of every 100 people in the labor pool are unemployed. But how can we say 4.7? I've seen surveys that say that the average number of children that people have is 2.5. Well, how do you do that? Unless we're talking about, someone that's pregnant and that's the portion of the person. So we really can't, it really doesn't really make sense. We could say about 5, but it's accurate, but maybe not so much. Um, so maybe we could get a larger sample and then change it to over 1,000. And so then we can say 47 would be unemployed out of every 1,000. So that makes a lot more sense than having that portion of that person, right? So yeah, so there's different ways we can see percents. Okay, here's another one. This is it can get see, but these examples might seem like they're crazy and out there, but they're used. Just like, we talked about misleading graphs, just like fractions, 3 or the proportions, 3 out of 4 dentists, you know, love Crest or whatever. But how many dentists did we survey? I mean, how is that? Here's another one. Tomorrow there's a 30% chance of rain. What does that mean? 30% of what? So it's 30 out of 100, but 30 out of 100 what? Are we talking about rain tomorrow? A 30% chance of rain means that 100 days have similar weather conditions to today's and it rained 30 times. I don't know. So, looking at percentages is just an example of that. But we will get into more dealing with the probability, and that we'll get more into that later, the likelihood or the chance of things happening. So that'll be for later, but it's still an example of percents that we will get into later. Okay, example 5. The credit card offered by Big Bank has a 12.9% interest rate. Okay, you've heard that before, right? This is right up most people's alley. So interest rate is based on the amount borrowed. So we kind of think about that. The interest could be $12.9 for every dollar of the balance, or really $12.90, right? Because we're talking about dollars. But that wouldn't be correct because credit cards are usually have the monthly payments, but the interest rates are stated annually. So it would be 1/12 of the $12.90, or about $1.08 every month. Although for every $100 balance, $12.90 per year would be charged, but that wouldn't be how much. You couldn't figure that out based on your statement for the month, how much the interest rate would actually be, because it wouldn't be 12.9%. off of that $200 that you have in there. It would actually be that $1.08 approximately for every $100 balance. So if you had $200, that would be $2.16 that you would see. Okay? So there's that. So we have to really pay particular attention to the unit, um, the what they're asking for. Okay, the rate and the base. Here we have another example. This might sound a little weird because a lot of times we've heard that there's nothing over 100%, right? The inflation rate in Zimbabwe in 2007 was 976%. Okay. 976 out of every 100. So prices can change that much. They can go up that much. If a loaf of bread costs 100 Zimbabwe dollars, or whatever they call them, or whatever country, then the price would change by 976 Zimbabwe dollars during the year. So that would change from, and that's a lot. That's a lot. Originally, it cost 100, and then it went to 1,076. But yeah, it's possible, and that percentage did go up by that much. So a percent larger than 100% is possible, although not in all cases. So Obama could not have made more than 100% of the vote. Well, unless you see all that what they talk about voter fraud, then that's possible. The employment rate can't be more than 100%. It's just not possible. And the chance of rain couldn't be more than 100%. Even in those places where it's humid and rainy all the time, it's not possible. But there are still examples when you would have rates that would be over 100%. So that's the first section. That's just a little bit of an overview. We need to talk about percents and numbers and how they relate to decimals and fractions, and how to switch them over. And you saw a little bit about this in the last chapter. We're going to do a little bit more of that. And first, we're just going to look at the numbers themselves, and then we're going to apply it, because that is so important. And that's what this class is about, is applied business math. So we're going to not only look at the numbers, we're going to take certain scenarios, and we're going to say, okay, how does this fit into this scenario? Why is doing these percent conversions important? Well, here we go. Okay. So first, we're going to convert percents to decimals. Okay. Now, percents are parts of 100 or hundredths. Remember that? Okay. So, excuse me. So we are just changing the percent to hundredths. And hundredths is how many places on the right side of the decimal point? 2. That's right. Okay. So we're going to change each of the following percents to a decimal. So there are a lot of ways we can do this. Now, I have told you that, I grew up back in the day when we had just math. And now there's new math, new ways of solving problems and doing things. The important thing is you get the correct answer, because the answer hasn't changed. It's how you go about getting it. And so for a lot of these, there's going to be a couple of ways that I'm going to, one, what one way to do it, and then another way to do it. And no way is right or wrong if you get the right answer. So basically, because these are hundredths, we are going to multiply each one of these by 0.01, because that's the hundredths place, right? So if we take 35%, we would say 35 times 0.01, which will give us 0.35, which 35% is the same as 0.35. But I would like to suggest that I find it easier, and how I learned was that when we move something 100th, we're moving it 2 decimal points. So we're moving it 2 decimal points to the left, okay? Not to the right, to the left, to make the percent to the decimal. So 35%, you take that 35 and it's understood that the decimal point is at the end of the 5. So you move it in between the 3 and the 5, and then you move it one more, and the answer is 0.35. So you can do it that way. It's up to you, really. You could also check your answers. So with the different ways of solving problems, you can check your answers by doing it the different way. And if you come up with the same answer, then guess what? You're probably right. 128. You see that when we multiply it by 0.01, we get 1.28. But there again, I'm going to move my little decimal points and I'm going to get 1.28. So, like I said, up to you. 3.57 becomes 0.0357. So, either way that you would want to do that. And then that talks about that too. Okay, so now we got something a little bit more crazy. We're changing 36 and 2/7% to a decimal. So I know it gets a little bit crazy. But just think about it. Okay. The one thing you cannot do on this one, unfortunately, at first, is you can't just say, oh, well, I'm going to move the decimal point 2 places. It's 0.36 and 2/7. Nope. Can't do it that way. So what we are going to do is we're going to keep the 36. Now we're going to change 2/7 into a decimal. And you can do that by taking your calculator and putting 2 divided by 7. And then you're going to get the number 0.285714, blah, blah, on and on and on and on, right? So then we would take the 36.286 times it by that 0.01, and we get 0.36286. At this point, after we moved the 2/7 and made it to the decimal, you could do the moving the decimal thing and make it 0.36286, but you cannot do that before you change the 2/7 into a decimal. Does that make sense? I hope that makes sense. Everybody got that? So 36 and 2/7 would be 0.36286. Excuse me. You saw the decimal places, and there was a bunch. Usually, the problem will tell you which what to use. Usually, you don't round until the end, especially when we talk about salaries and things. I think we talked about that last chapter. So next is example 3. We're going to change percents to a simplified fraction. So how do we do that? Well, instead of the 0.01 that we did before, now we are going to multiply by 1/100th to get the difference between the percentage and the fraction. So if you have 12%, you take 12% and you multiply it by 1/100, which is 12 over 100. Because remember that if you have that whole number 12, it's really 12 over 1. It's understood. Okay, so you're multiplying 12 times 1, which is 12, and 1 times 100, which is 100. And then you're simplifying it to its smallest form, so where no numbers can be divisible by any of the other numbers. So we know that 12 100ths, we can think about it, and you might, and it's all right if you go and do this, you might say, oh, well, I know 2. So I'll take it to 6/50ths. And it's like, oh, that's not in simplest form yet, is it? No, 3/25. And you probably will be marked wrong on answers if you don't take it to the simplest form and it asks you to do that. So just a quick thought about that. 300%, do the same thing, times 100. We get 3. 7.3, look at that. That's a little bit different. Okay, because it's got that 7.3, it's not over 100 now, it's over 1,000, because that's actually saying 73 over 1,000. It might be 7.3 over 100, but we don't want to leave that decimal point in the numerator of the fraction, and so that's why we change it over to 73 over 1,000 on that one. Okay. Uh, let's see. Okay, here's another great one. So on this one, we're not changing to a decimal. And last time, remember when we changed to a decimal, we said we took the 2 divided by the 3 and got that answer and said 16 point, and I think it's 0.667, I think, or 67, somewhere around there. But anyway, so it'd be 16.667, and then you would times it by the 0.01 or move the decimal point and be 0.1667 something. So we can't do that here. We are going to, because we're turning a mixed number into a fraction. So we will start by making an improper fraction. So when you're looking at that, you've got 16 and 2/3. So how do you make an improper fraction? 16 times 3 plus 2. That gives you 50. 50 over 3%, which is 50/3. Then we're multiplying it by 1 over 100 again, which gives you that 50 over 300, which simplified gives you 1/6. So 16 and 2/3% is 1/6. Okay, so now we're going to change decimals into percents. So what do you think on this one? So 100%, remember, is equal to 1. So we're going to multiply each of these times 100%. That's the one thing you can do. Remember my other little trick. Okay, so this time, instead of moving the decimal point to the left, we're going to move it to the right. So instead of having 0.85, your answer is going to be 85%. So, and you see that when you say 0.85 times 100, then I hope this doesn't reset again. Anyway, we might have to stop and start over again. But anyway, the 0.06, remember, move it 2 places to the right. So we got 0.6, or we multiply by 100%. And that's how we get the answer on that one. So there's your answers. Okay, another example. Oh, now we're going to take fractions and they're going to become percents. So on that one, we are going to say we've got 4/5, right? We are going to multiply each fraction by 100%. So the first one was 4/5. 4/5 times 100%. We can change that 100% to 100 over 1, right? Because we understand that a whole number always is over 1. So when we do the multiplication, we have 400 over 5%, and then that becomes 80%. 2 3/4, we change that to the improper fraction. So 2 times 4 is 8, plus 3 is 11 over 4, which gives us that 11 over 4 times 100 over 1%, and we end up with 275%. Um, on that one, an interesting thing that you might, well, all of them actually, but 4/5, is 80% and the decimal is 0.80. When you look at that 2 3/4, remember how we changed them to the decimal and we had to say the 3 divided by 4? So that one, 3 divided by 4 is 0.75. So that decimal point would be 2.75. Um, and then you got the last one, which was 3/7. And so you find the answer for that. So, and then when you saw on that, we did a little rounding. So that can happen. You might have to round. But just make sure, um, if the problem says a certain number of decimal places, you've got to put those. Um, and also, it's just important to keep accuracy as much as possible, when you are doing percents. So, whew, okay, we are a portion of the way there. I think there's 6 sections. I think we're on 3. Let's see. I don't know. It might be. We're gonna get there though, I promise. Okay, next, basic percent problems. So we're gonna look at some generic percent problems first, and then we're gonna go into more of solving like word problems. Okay, so we're looking at, the first one was 40% of 108 is what number? 40% of what number is 108? And what percent of 108 is 40? Each have a different answer. Okay, they might look a little the same, but we'll see. We're gonna get into that. So we recognize that there are 3 quantities in each problem. There's some percent, there's some number, and there's some other number. Okay, rate, base, and part is really what they are. We're looking at R, P, and B. And we can set up formulas based on that. And we have different formulas. We can look at, P is equal to B times R. B is equal to P over R. Or R is equal to P over B. So let me go through those again so you can write them down. That'll help you. I also have a little circle graph coming up, a pie chart kind of thing to help you with that too. So rate is the percent. That's always a percent. Rate percent of the base, which is B, is P the part. So the part is equal to the base times the rate. So that's P is equal to B times R. The base, excuse me, is equal to the part over the rate. So B is equal to P over R. And the rate is equal to the rate over the base. So rate is equal to P over B. So yes, we're talking about PBR. um, I thought of a funny joke about that, but I can't remember oh yeah, Professional Bull Riders Association. We're not talking about the Professional Bull Riders Association here or any other PBRs. We are talking about the PBRs related to percentage and base. The percent problems can be solved also using the following proportion. R over 100 is equal to P over B. We looked at proportions before. That's basically how you can use to answer the problem. So we're going to look at that. We're going to look at a different way to do these as well. But when we first start up, for your first example, 40% of 108 is what number? So we use R over 100 is equal to P over B, right? Okay, so the rate is 40. The number following the phrase percent of is 108, so it's the base, or B. And the missing value is part, so P. That's what we want to know, the part, because we're looking at a portion of 108. So we got 108 is the big picture, and we want to know what 40% of this big old 108 is. Okay, so that's what we're trying to figure out. Okay, so we're cross multiplying. P is equal to 40 times 108 divided by 100. So basically, I would say 100p is equal to 40 times 108. You would get the answer for that. So 40 times 108 is 108 times 40 is 2, 3, 4, 4320. 4320. And then we would say divided by 100. Okay, because we're saying 100 times p, and we're trying to find the value of p. So when you do that, you get 4320 over 100, which ends up being 43.2. So that's your part. Your part is 43.2. So if you have this big circle, and that big circle is 108, 40% of that is going to be 43.2. So you can kind of see that would be right, because if you looked at 50% of 108, which would be half, right? So half of 108 is divided by 2 is 54. So a half would be 54. So 40%, that makes sense, 43.2, right? Okay. Now, here's this next question. 40% of what number is 108? So look, this is a little different, because the what number is the big part that we don't know, right? Because we only know 108, which is the portion, or 40% of the whole. So that's why we need to figure out the base in this situation, or the B. So we can set it up like this. 40 over 100 is equal to 108 over B. And again, I would solve it. 40 times B is equal to 108 times 100. And you would get that answer. Should be 27,000 divided by 100 will give you 270. So 270 is a big circle. Okay. And that's the base. And then we're taking the part, or the piece of it, which is the 40%, which is 108. Okay, then what percent of 108 is 40? So again, we can set it up. R over 100 is equal to P over B. We don't know the percent, right? What percent? And so that's always the rate. The percent is always the rate. So we set it up this way. We're solving for R. We're saying 100 times 40, and then divided it by 108. And we're going to get 37.037. So again, we're looking at, 108. What portion is that 40? What part is the 40? Okay, and that is where we come up with the 37%. Okay, so we found the part, the base, and the rate in these examples. So you can look at and figure out these problems based on that. But we are also going to look at some applied examples, because that's what this is, applied math. So here we go. A newspaper reports yesterday the new unemployment figures were released, showing a county-wide unemployment rate of 7.5%, which is equivalent to 14,350 unemployed persons. What is the size of the labor force in the county? So if you look back at our picture again, we want to know the size of the labor force. We want to know the big circle. We only know that 7.5% of this big circle equals 14,350. Okay? So we know the rate and we know the part, right? So we want to know the base. So there again, we would do the cross multiplying. We would come up with our answer, which is 191,333. So approximately 190 in the big circle, okay, for the county in this situation. Okay, we did round. Okay, think about the rounding if it asks you for rounding. Next example. Eduardo is one of several partners in a business. His share of the income is 37 and 1/3. If the income of the business this year is $6 million, wow, wouldn't that be nice? Even being one of several partners. But which portion is Eduardo's share? Okay, so again, let's see, what's the rate? 37 and 1/3. Okay. The base is 6 million, so isn't the big part is the base. So instead of writing the whole 6 million out, we can write 6, but remember, we need to make sure that we remember that is in millions. Back to our misleading graph, making sure that we're looking at, the exact figures on that. So in this case, we are looking at 37 and 1/3, which we make into 112 over 3. Remember, we do that by saying 37 times 3 plus 1, which gives us 112 over 3, times 6 divided by 100, and you get the answer of 2.24, which means that Eduardo's share of this $6 million is $2.24 million. Okay, that's 37 and 1/3. So we did need to change that mixed number. You could have changed it to a decimal or fraction. Remember I said that the rate is always the percent. Well, we can change it to the percent, and that's the rate on that. But if it's in a decimal or a fraction, you could still change it. But if the answer asks for the percent, remember to give it in the percent form instead of the fraction or the decimal. Here's another one. This one could be a little bit difficult if we don't think about it, right? So you have to look at what it's asking. So it's saying at one company, 30% of its employees are women and 165 employees are men. How many employees does the company have? So it's not gotten it in the same form, does it? No, because it's got 165 employees are men, but 34% of the employees are women. So again, if we have the whole, we don't know the whole, do we? We don't know the base. We know the portion that are males, we know that there's 165 employees are males, are men, but we also know that 34% of them are women, but we really don't know yet how many total employees. So, but we can't say 34% of the employees is 165 because that's not accurate. 34% of the women are make up the whole, but 165 employees are men. So if we wanted to find out the percentage of men, we would subtract the 100 because 100%, the whole, minus 34% is 66. And then we could figure it out from there. So we would find out that the whole is 250 employees. Okay. So that's another example. Okay. Here's my PBR diagram. So we use formulas for the other ones. We also have this cute little PBR circle. PBR circle. So the PBR circle will help you to solve the problems. And again, it's written down the PBR formulas, the uh, rate, base, and part base, and race rate. So the way you can do this. So we looked at proportions, we looked at the problems. So, but you can also cover up what you're trying to find, and then what's left is the formula. So for this example, okay, I don't know the part, right? So I'm going to cover up the P. So try to do that. Cover up the P, and what's left? B and R. So the formula will be P is equal to B times R. Yeah? Okay. So here's another one. I'm looking for B. I'm looking for the base. So cover up that B. So B is equal to what's left? P divided by R, because they're on opposite sides. So it's not multiplication like it would have been on the other one. It's the division. So there again, okay, we want R. So cover that up. What's left? R is equal to P divided by B. So just another way to kind of help you look at that, and hopefully that could help. We're going to look at this in 1 year's time. A $250 deposit earned $8 in interest. What was the interest rate? So we don't know the R, right? So we go back up. We don't know the R. So we cover up the R. R is equal to P divided by B. So the part divided by the base, right? So the rate is equal to part divided by the base. The part is 8 because that's your interest, and your 250 is the deposit. And when you divide that out, you get 0.032. Remember, we're looking at the rate, so we will typically would like to see that in the percentage, so that would give you 3.2%. Again, you can multiply it by 100, or you can just move that decimal point 2 places to the right and get 3.2. Okay? All right. Again, another one. The part is missing. Okay? Again, if we look at this, let's go back into our PBR, not our professional bull riding. Cover up the P. P is equal to B times R. Okay, so we're going to take the base times the rate. Okay, so here we go. Is that the right one? Hold. I think I went too far. No, I didn't. Anyway, hold on. So the base times the rate. The base is 300. And we want the 9.6%. So the part is 28. $28.80 because the sales tax is, so the sales tax would be $28.80. Okay, so let us go into percent change. And we're on 2.4. Not bad, we're getting there. We'll get there. So we are measuring, when we talk about percents, we're talking about a part of the whole, right? The part of the whole. But we're also talking about, when we talk about percents and percent changes, we're talking about comparison or changes between two amounts. And this kind of goes back to the one about Zimbabwe and it being a greater percent than 100. So that's what we're talking about on here, is 1% change and where it can be greater than 100. So we still look at base rate in part, but we also are looking at adding and subtracting to get a new total. So when we look at this, I'll give you the first example. The average price of a house in Kansas City is in 2016 was $152,000. If the housing prices increased 13.4% over the next year, what was the average price in 2017? So remember that the percent change is the part added or subtracted from the base to produce the new total. Okay, so 152,000 is the base. All right, so we could say easily, we could say P is equal to B times R, because we want to find that part. And for that, we would say the 152,000 times the 13.4%. And that would give us 20,368 is the part. Okay. But a great way to do that, and then that's not the answer, that's the part, is to set up a diagram. So there's actually 3 rates we need to look at, and 3 dollar amounts. So this right side is the dollar amount where it has 152,000. So we're looking at the old, the change, and the new. Now, in some cases, that change would be subtracting. But in this case, we know, because we looked at this, that it says an increase. Okay, so make sure that when you do the problem, you know whether it's the plus or minus, because if not, you know, that will be incorrect. So when we first look at this, we know that we start with 100%, and then we have the 13.4, which is the change, and then we know that 152,000 is the original rate. So then we do that math that, you know, when I said P equals B times R, and I said 152,000 times the 13.4, and we got 20,368, right? So the increase in the prices was 20,368, but that's not the new price. That's the increase. Okay, that's the portion or the part that it increased. And so really, to get the new, you would say old plus the change would give you the new rate, the new price. And also, the 100% plus the 13.4% gives us 113.4%. See, over 100% because the change was over 100. And so, to fill in the chart, these are the answers that you would get. So 152,000 plus 20,368 is giving you 172,368 as the new average housing price for the new year. So, things to think about. And I would write this down. This is important to solve a percent change diagram, which is what we're doing. The little diagram, setting it all out. The old percent is always 100. Okay. If two quantities appear on the same side, add or subtract to find the third quantity. So, again, what that means is the ones on the left-hand side is what you add or subtract, and the ones on the right-hand side is what you add and subtract. Okay? Use two rows and solve a proportion. Okay? And then add or subtract to find any remaining quantities, because you can solve the proportion, because when you see this, you would see that it was 100 over 13.4, so 152,000 is the old, and then it would be over X, and that's where you would find let's see if I can okay, so I could say 100 over 13.4 is equal to 152,000 over X. So I'm cross multiplying that. Okay, that's my proportions, and I want my proportions to be equal. So then I would say 100x is equal to 152,000 times 13.4, right? And then I get the 2368 on that one. Okay. So, yeah, make sure you have that to solve a percent change diagram. Those are the steps you need to take. So we're gonna fill out one. We're gonna do a few of these. There's not much in this one, is there? But what do we know? We know that the old percent is going to be 100%. That's what we always put in there. So we know it's 100%. We know we're changing it. We're adding, so it's a plus 9%. So the ending percent would be 109, right? So we just got to figure out the other side. So see, we have that side figured out. And we have the bottom number on here. Okay, so what are we going to use? We're going to use something to solve the problem. We don't have enough information in the right side of the problem on the first two rows, so we're going to have to use the first and the third rows to solve the problem. So we're gonna know 100 and 109, and we're gonna have the numerator will be the x that we're looking for divided by the 455.62. And so basically you're setting up the proportion in that same way. And so here's kind of what I wrote earlier. The 9 over the 109 is equal to the change over 455.62. Or you can use x or whatever number you would like to use. So we solve the proportion, and we get our answer, which is 37.62. So then we have this number in there. So now we only have one number left. So we want to know what the 100% would be. So we actually, because we're going from the other end, we have to subtract it, because this, the number that we started out, the 100%, was smaller. So the old, because we're adding the change, and so we would subtract, and we would get $418. So there's your little diagram. Um, there's several of these on your homework that I know that you saw or you will see if you haven't done it yet. So just take those steps and you can solve the problems in that way. Remember to make sure that you know whether the change is for the positive or for the negative. Um, and it might take longer, but it does help to set it up, and it puts word problems for a lot of people are kind of difficult to really get. And so I think if you use the diagram, it might make it easier to set up the problem. Because, like, for example, you've got a 40-inch TV originally sold for $249, but the dealer marks the price down 20% for a sale. And we want to know the sales price. So if you set up the the diagram and you set up the old, change, and new, you know that the original price or the old price was 249. So you can put that in that top block of the of your diagram. And we also know that he marked it down 20% for a sale. So he marked it down. So we know we're going to subtract, and we know that we have the 20. So we put the 20 in there. Now, remember, the old percent is what? Always 100. So that's 100 minus the 20. So we know that the new percent then would be 100 minus 20, which would be 80, right? So we got that part. So I got all that figured out. I'm looking for the sales price or the new price. Um, and we kind of added a new column, but it's just showing that what the sales price would be. So we're setting it up again. We're going to use the first and the third rows. So we're going to say 100 over 80 is equal to 249 over what? X, the new rate, right? 100 times X is equal to 249 times 80. We end up with 199.20, which would be the new price. Okay, and that's where you put that in the diagram for that. Um, okay, let's see. After a 22% increase, a lawn tractor sells for 17.85. What was the original price? So, actually, this looks like a typo because it should be, this one should be 22. It ends up being the right number, but that should be 22%. But here again, we set it up. We're looking for the original price. So we set up a proportion. So we're saying the 100 over the 122 is equal to the old, because that's what we're looking for, divided by the 1785. And cross multiply and give us 1463.11, which was the original price of the tractor. Whoops. There we go. Okay. So we can't take, we might want to just say subtract 22 from the new price, but we can't do that. So make sure that you are doing the formula, how it's set up, because it'll give you a different answer and it will not be correct. And you're going to wonder why, but set it up in the diagram and you'll be good. Okay, so sales at Marla's Music were 292,000 last month and 328,000 this month. What was the percent increase in sales? So here's our diagram. We know 100%, of course, because that's always the original. We're looking for the percent change. It was, let's see, 292,000 last month and 328 this month. Again, this should say 292. So this is not the right answer right there. Um, so that's another typo. So 100 times the 32, 328,000 is equal to 292,000 times new or times X. We solve for X and we get 112.33. So then the percent is 12.33, the 12.33 increase in the sales. So, and like I said before, using the diagram does take a long time, take longer, but so you can do the PBR formula, the correct PBR formula for what you're looking for, and it would be faster. But just for ease in solving the problem and figuring out where to put everything, it's just a good different way to solve it. Um, and you can always check your work by doing the opposite. So that always helps too, because you know a different way to solve it. So we also talk about the complement of the change percent. Okay. This is for a percent decrease problem. So the new percent is always obtained by subtracting the change percent from 100. And that's your complement. So for example, 80% is the complement of 20% because 100 minus 20 is 80. Okay. So when we look further into that, this is why we want to think about that. Because for this example, Regina earns $833 per week, but 29% of it is withheld for taxes. What is her pay after taxes? So we don't want to say, we don't put 29% in the problem. She keeps the complement of 29%. So she keeps 71%, right? Because 100 minus 29 would be 71%. So we're going to use that as the rate. 833 is the base, and we want to know the part. Okay, because we want to know her pay after taxes. It doesn't say how much is withheld. It says what's her pay after taxes. So we're taking out the 29. We are saying P is equal to B times R. We're going to say 833 times 0.71 is going to give you the part of 591.43. So her net pay is 591.43 per week. Again, make sure you're looking at what they're asking. They did not ask how much is withheld. Okay, if they asked how much was withheld, it would be 833 times the 0.29. But they want to know what is her pay after taxes. So that's she would be keeping the 71%. Okay. We also talk about augmented percentages, and that's adding and making it higher. So augmented percent. 100% is the augmented percent of 20% because we're adding the 100 to that 20%. So Brianna's purchases at the grocery store subtotal $135.42 before the 8.5% sales tax. What is the total after the sales tax is added? So she's got to pay the subtotal plus the tax. The rate is 8.5%. percent augmented or 108.5% of the 135.42, so total. So if we use the P is equal to B times R, we have the 108% and the 135.42, and that gives us the answer. Another way that you could do it is you could say 135.42 times the 8.5% or 0.085. That's going to give you the amount of the sales tax, but it does not get you to the total after the sales tax is included. So if you did that, you would have another step. So this is just another way of doing that. You can either augment it by making it 108.5%, and multiplying the 135.42 times that 1.085, or you can say 135.42 times the 8.5%, which is 0.085, get that answer and add that to 135.42 to give you the 146.93. So different ways of doing it. Come up with the same answer. Whatever works best for you, however you can find the answer, that's the way I want you to do it. Okay? Whew. Okay. I think this is the last section for this chapter. I need another break. And if you need a break during any of this, you can always stop it and then come back to it. And like I said, if you need to review some of the other chapters, you can redo that too. Okay, so 2.5, compounding of percents. Okay, this is not fun, but we're going to get this because once you think about it, it makes sense and it makes it easier. So, um, we're looking at the compounding of percents or percent changes occurring over time. Um, and we might think that we might think for compounding that we would just say, for example, if, and we're going into example one, but Calvin received a 10% raise last year and another 10% raise this year. What is the percent increase in his salary for the 2-year period? Well, I would say 20%, right? We can't do that, unfortunately, because what we're looking at is the fact that the bases are changing. So if he made a certain amount last year and he added 10% on that, then we're originally talking about this number. So say, for example, 35,000 times the 10% is equal the number that it comes out to. So the next year, when we're taking the 10% again, we're taking the 10% off of this new number instead of this original 35,000. So it can't be 20%. So that's why we need to look at it a different way. So in this example, and I use 35, and in this one, it doesn't have an original salary, and it's like, well, what the heck am I supposed to do? Well, we're going to just put in a number, and we're going to figure it out from there because we know that we don't need to know it to get the right answer. So we would do the multiplication twice. So we would say 36,000 times 1.10, which is 10%, times 1.10, which is 43560. So his salary in 2 years would be for $43,560. So we want to know the percent increase. So we're going to set up that little handy dandy chart again, the diagram, and we're going to have the old, the change, and the new. So we know that from the little numbers that we talked about, that the top on the right is 36,000, and then the bottom is 43560, or 43,560. We know that the original percent was 100, and so we're going to do that little proportion thing again, and we're going to do the first row and the third row. And so if we do that, we're going to cross multiply again, 43,560 times 100. Divide that by 36,000, we get 121%. So the new percent is 121. So he received a 21% increase. So, like I said, it looks like it would be 10 plus 10, which is 20, but it's more than that. He got in more than that. So that's something that you really need to think about again, with working. If you're in human resources, if you do payroll, um, even if you were looking at your salary increases and go, this doesn't sound right, even though, 21% is more than 20. So you would be like, do I say anything or not? Because it should be 20, but no, that's not right. They did it. They did it right. It is more. Um, so um, there you go. And then, of course, like I said, the diagram takes longer, but so you can do it a different way to figure that out as well. So that just gives you an example of that. Um, Here's another one. We're going to look at compliments on here. Bob purchased pencil sharpeners. His supplier gave him a 15% discount followed by a 5% discount. So we want to know the total discount. Okay, it's not 20. So we're going to take the complement of both and multiply them together. So we're taking the complement of the 15 and getting 85, and the complement of 5%, which is 95. Remember, it's the 100 minus the original. And we get 0.8075, which is 80.75%. The complement of that is 19.25. So he got a total discount of 19.25. So here it's a little different because before, even though he got two 10% increases and we thought it was going to be 20, it ended up being like 21. And in this case, he had a 15 plus a 5, which looks like it would be 20, but he didn't. He got a 19.25. So yeah, that it looks like another trick question. It's really not. It's just trying to help you to understand that, it doesn't always come out the way you think it would. This one is a little tougher. A bookcase originally cost a dealer $50. The dealer marks it up 20% above his cost and later reduces it 20% for a sale. What is the sale price? Well, you would think that the sale price would be 50, right? Well, that's not exactly what it is. Hold on just a minute. I took too long. I guess an hour and 15 minutes is longer than the computer can stay open. So let me open us back up and get us going again. Take a deep breath. We can get through this. We're almost done. Loading, loading, loading. Okay. I know you didn't want to hear me sing. So let's go. And sometimes it takes a second. So it depends on how fast your computer is or isn't. um, let's see, we did that one. Okay, we did that one. Okay, here's where we are. Okay. So, oh, it does that too. Okay, so example 3. So you would say $50, right? But they don't cancel each other out, because we're looking again at the augmented percent, which would make it 120. So we're actually, the new price would be, we're still using that same formula, P equal B times R, but we're saying 50 times 1.20, which takes into account that augmented percent, which is 60. Um, and then the reduction of 20% gives us a complement of 80. So then we would have 48. So the sales price would be $48, not $50. So that's another one to take into consideration. Go back when you're doing your homework and look at these and just follow the examples. Um, so the 20% increase was based on a different price. Remember, just like when we saw the salary and the salary changed, the different price. So that could happen too. Um, percent decreases will not cancel out percent increases, and percent increases will not cancel out percent decreases. So that's something else to keep in mind. Um, Example 4, a dealer normally marks up his merchandise 30% above his cost. What percent markdown from regular price can he advertise if he wants to place merchandise on sale at his cost? So it's not 30. Again, just know it's not 30. We have to use that augmented percent of 130. It doesn't give any prices for this either. It doesn't give any cost. Just put in something that makes sense, that might be easy to uh, to calculate. So the original price is that 100%. So we're going to say that it was $130. Um, and then we look at the difference there. We have the diagram, um, which is easy to set up when we do that. And then we can do the proportion. Again, this would be the first and the third lines. Again, 100 over X is equal to 130 over 100. And then you do the multiplication and you get the 23.08%. Um, so it's not a 30%. It was a 30% increase. But then we have a 23.8% markdown. We probably wouldn't want to exactly say it that specifically. I mean, you might. But for example, the dealer's advertisement could say prices marked down over 20%, which is true. They were marked down over 20%. Um, so again, the part and the base have changed. So remember, this is not the same as it was before, and the part is not the same as it was before. So we can look at different methods to do that. This is giving you another example, um, but using that chart is a great way to um, solve those problems. Um, the inverse of a 40% decrease, unfortunately, is not 60%. Um, but you can divide by the complement of 40, which would be 60. So a 66.67% increase is the inverse of a 40% decrease. Okay, so we have another example. What additional percent change is needed to change a 25% decrease into a 30% decrease? So again, we can't take the easy route. We have to look at the Um, we're looking at the complements on these. And so we would look at the 75 and the 70. We would do the cross multiplication, the proportions, and we would come up with the 93.33. And then using the subtracting from 100 to get the 6.67. So make sure that you are actually pulling what you need to on that. Okay, well, that is that chapter. You then have, of course, the chapter exercises at the end of the chapter. The first section you want to look at what's the base. So what's the base? Okay. And this is not, in the formula specifically, it's just writing out what the base would be. It says in a survey, 23.3% of adults said they formerly smoked. So the base would be all adults who formerly smoked. No, that would be the part. All adults would be your base. Oh, sorry. So then you just looked at those on those. There's a few of those. Remember too, when you're going through these, you can either hit the next button right here. Do not hit that next button because it's not going to give you the right place. Or you can go to item 2 and you can look at these that way. So I think I did have something, maybe. So just basically on these, it said about 14% of the bank robbers convicted nationwide last year were repeat offenders. So out of every 100 convicted bank robbers, there were 14 repeat offenders. Okay, so that's what we're looking at on that one, on those, and the other ones would be the same on that. Let's see, item 3, basically the same as what was in item 2. Here we're changing to a decimal. You see that and it might say, it says on mine, I don't know if you've got the same questions. Some of them probably change. But round to 4 decimal places. So, and remember, you got to say 1, but then you got to say 2 divided by 5, and 5, find that decimal point and work on that to find the decimal. Then we're finding fractions. Make sure, again, it says simplify the answer. So the fraction 49 over 100, is that simplified all the way? Probably. So that's okay. Change it to percent. Again, we're multiplying, or you're moving it, and then you get the answer on that one. Find a percent from a fraction, rounding to 2 decimal places. Then we're starting to solve problems with the rate and the base and the part. Remember, you can use this. You can use the circle with the P, B, and R, the professional wool riders, or you can use the formulas on that. We start getting, instead of just the questions, we get into some more, some applied examples. So you're going to see that too. Just remember to think about it the same way as you did the other ones and look at the wording. And so, for example, Stone Age Keepsakes has 174,500 in sales last year. They spent 12,422 on advertising. So they got 174.5, and then they spent that part. So we're looking for the percent or the rate. So that's what you need to look at on that one. Again, That's what all of these are. Then you get into these little table things. So, um, again, 100 plus 7 is 107% because you see the plus change. And then you do the proportions and cross multiply and find the answers on those. Okay, so that's what those look like. There's quite a few um, of those. Um, Here's some percent increases, and you're going to go through basically all the ones that we talked about. So they're going to be the different scenarios, and then there you have those. And then there's a couple of questions toward the end. What is the largest possible percent decrease, and what's the largest possible percent increase? So those are just some things to think about too. Just putting your thinking caps on, your critical thinking skills to work. And I know it says 10,000 word limit. You don't have to even come close to that. Um, that's just what the box is giving to you. So anyway, that is chapter 2. That is fundamentals 2. Um, a lot more about percents than you ever thought you would ever want to know, but there you go. So if you have any questions, please let me know. I'm here for you. Keep going. If you've submitted some and you want to go back and look at them again, you can do that. Um, but let's keep chugging along. Those next chapters on statistics, and we have a project for that too. So take care. See you soon.